So talking about quotients for a second. So if we had a function like y that was made up of a function on top divided by a function on the bottom, we might hope that the derivative would just mean taking the derivative of the numerator divided by the derivative of the denominator. That would make sense if that was the case, but unfortunately, it's not quite so simple. We have this new thing here called the quotient rule. You can see it here written as b of x times t prime of x minus t of x b prime of x all over b of x all squared. I like to think of this, though, again in words, where if you had low underneath and high on top, I like to think of the quotient rule as low d high minus high d low all over the square of what's below. So let's think of it that way. You can see it either way here, but I like to just write it in words again in a lot of cases like that. So let's start with this function f of x equal to x squared over 2x minus 1. We got our high, we got our low. So by the quotient rule, what we do is we write it like this. We write low, the 2x minus 1, times d high, derivative of what's on top, the derivative of x squared being 2x. So that's low d high minus high x squared times d low, which derivative of what's underneath, which is just 2, all over the square of what's below. So take what's underneath and just basically put it in parentheses raised to the second power. That usually will do the trick. We do need to simplify things down a little bit so we could distribute when we need to. So distributing here would give us 4x squared minus 2x minus 2x squared all over 2x minus 1 in parentheses all squared. And that would simplify down to 2x squared minus 2x all over 2x minus 1 in parentheses all squared. This one, f of x is equal to t squared minus t over t to the third plus 1. So think of the quotient rule. We've got high over low. And so f prime of x, we do up on top, we do again low, derivative of high, d high, minus high times d low. So on top, we're going to go low, which is t to the third plus 1 times d high. Derivative of what's on top is 2t minus 1 minus high t squared minus t d low, 3t squared, all over the square of what's below, t to the third plus 1 in parentheses, all squared. Okay, there's a considerable amount of things to do here in order to simplify it, but it's not anything too crazy. So first off, you'll have to make sure to know that these two things here in front multiplied together in parentheses, you will need to FOIL those out, and then also distribute the 3t squared across those two terms. Okay, I won't write out all the steps of FOILing. If you'd like to pause the video here and see if you can get it FOILed and then see where I go after that, that might be a good thing to do. That way you can practice the FOILing steps. This thing FOILs out to be 2t to the fourth minus t to the third plus 2t minus 1 minus 3t to the fourth plus 3t to the third, all over t to the third plus 1 in parentheses squared. Then combining like terms, we will get this looking like negative t to the fourth plus 2t to the third plus 2t minus 1 all over t to the third plus 1 all squared. Here, let's look at the function 3e to the x over 1 plus e to the x. So high on top and low underneath. So according to the quotient rule, we go low, 1 plus e to the x, d high, which is still 3e to the x. Low, d high, minus high, 3e to the x, d low, which is just e to the x, all over the square of what's below. 1 plus e to the x in parentheses, all squared. So what we need to do is take care to distribute into the parentheses. So what we're going to have here is 3e to the x plus 3 e to the x times e to the x minus 3 e to the x times e to the x, all over 1 plus e to the x in parentheses, all squared. One thing I will mention is when we have e to the x times e to the x, that's technically e to the 2x. So you could write it either way here. Either way, though, we see how we have plus 3e to the 2x minus 3e to the 2x. So those are going to cancel out. So we're going to have f prime of x is equal to 3e to the x all over parentheses 1 plus e to the x, close parenthesis, all squared. So here our function looks like f of x equals ln x over 2x plus 5. Find the derivative f prime of x. So we've got high over low. And by the quotient rule again, we go low, d high to get started. So low be 2x plus 5. D high is the derivative of ln x, 1 over x, minus high, d low. So that would be ln x times the derivative of what's underneath, the 2x plus 5, which is just 2, all over the square of what's below. Okay, so what happens here is we can write this as 2x plus 5 all over x minus 2 ln x all over 2x plus 5 all squared. Now I'd like to simplify this sum. So what I'm going to do is I'm going to multiply through both top and bottom by x. I'll mention why I'm doing this here. If I multiply by x, I can get rid of that x that's underneath there. And so our derivative, f prime of x, could be written as 2x plus 5 minus 2x ln x all over x, 2x plus 5 in parentheses, all squared. In this particular example, it says that these total sales in thousands, t months after release, is given by this function s of t here. We're going to start by finding the derivative s prime of t. It's going to be quotient rule again. So we do low, t squared plus 100, d high, which is 250t, minus high, 125t squared, d low, 2t, all over the square of what's below. And I'll need to simplify that down a little bit here. So s prime of t would be equal to 250t to the third plus 25,000 t minus 250 t to the third, all over t squared plus 100 in parentheses, all squared. We'll notice how simplifying this down further, we could canceling out those terms. We have s prime of t is 25,000 t all over t squared plus 100 in parentheses, all squared. So that's the first part it's asking us here. Find the derivative. So now it wants us to find the original function s of 10 and the derivative s of 10, s prime of 10. Going back to the original function and plugging in the number 10, it would look like 125 times 10 squared over 10 squared plus 100. It's going to be equal to 12,500 over 200, or 62.5. Now that stands for the number of games sold in thousands, according to what they told us above. Now if we do this for the derivative, we'll have 25,000 times 10 all over 10 squared plus 100 in parentheses, all squared. So that's going to equal to 250,000 all over 40,000, which is equal to 6.25. Now, what does that tell us? It tells us that the sales are increasing by that much. So 6.25 thousand at 10 months after release. So we can use that to approximate how much there'll be after 11 months. So since sales are increasing by that many a month, if we take how many have already been sold plus the new amount that they would be increasing by, so 62.5 plus the rate of change, 6.25, we would get 68.75 thousand. So that should tell us the total amount after 11 months.